Welcome to Understand the Math. In this video, we are going to learn about ellipses, what they look like, what their key components are, and how to write equations that describe them. We'll start with an example that shows how to find the vertices, foci, eccentricity, and axes of an ellipse and sketch its graph. Then, we'll look at examples where we're given specific information, like the foci and vertices, the foci and major axis length, the vertices and minor axis length, or the eccentricity and foci, and use that to write the equation of the ellipse. Let's get started. We'll begin with some ellipse essentials, what they look like, and the types of equations that describe them. An ellipse is the set of all points, such as this point right up here, such that the sum of the distance from any point on the ellipse to two fixed points, this means this distance to this point, and this distance to this point, called the focus if it's singular, or the foci if they're plural, is constant. So we have d1 plus d2 is equal to a constant. That's what defines an ellipse. Every ellipse has a vertex on each end. We have one here and one here. It has a major axis, that's the longer axis, and a minor axis, which is the shorter axis. A circle is technically an ellipse, and it has a major and minor axis the same length, but we're not going to cover that in this video. If an ellipse is oriented horizontally, like this one here, it can be described by this equation. X squared divided by a squared plus y squared divided by b squared is equal to 1. When the ellipse is oriented horizontally, the bigger constant is under the x squared. With our picture on the right, the ellipse is oriented vertically, and it can be described by this equation right here, x squared divided by b squared plus y squared divided by a squared is equal to 1. Notice that a squared, which is the bigger constant, is under the y squared. If the bigger constant is under the x squared, the ellipse is oriented horizontally, but if the bigger constant is under the y squared, the ellipse is oriented vertically. In both of these ellipses, the major axis has a length equal to 2a, and that's this axis right here, or right here. And then the minor axis has a length of 2b, and the minor axis is either here or here. Let's now talk about what's called the eccentricity. The eccentricity of an ellipse is just a number that describes how stretched out it is. E is equal to c divided by a, where c is the distance from the center to a focus, and then a is just the length of what we call the semi-major axis. It's just half of the major axis. If e is closer to 0 than it is to 1, the ellipse is more circular, and if e is closer to 1, the ellipse is more elongated. So knowing the eccentricity really helps you understand the shape of the ellipse better. Let's now look at some examples. In our first example, we are going to find the vertices, foci, eccentricity, and then major and minor axis lengths, and then we're going to sketch the graph. We're going to do two examples like this. In our first example, we have the equation x squared divided by 16 plus y squared divided by 9 is equal to 1. Let's first find the vertices. In this equation, the bigger number 16 is under the x squared, so that tells us that our major axis is horizontal. Because our major axis is horizontal, our vertices are going to lie to the right and left of the center of the ellipse. Our ellipse is centered at the origin, so we can write down that our vertices are going to equal 0 plus a, comma 0. That's to the right of the center. And 0 minus a, comma 0. That's to the left of the center. Now we need to find a. Let's compare our equation to the standard equation x squared divided by a squared plus y squared divided by b squared is equal to 1. We know that the a squared is under the x squared because the a squared is always going to be the bigger constant. Let's write down that a squared is equal to 16, so that tells us that a is equal to 4. So we can go back up and write down that our vertices are 4, 0, and minus 4, 0. Let's now find the foci. The foci are also to the left and right of the center of the ellipse, so we can write them as 0 plus c, comma 0, and 0 minus c, comma 0. Now we just have to find c. We're going to use the formula c squared is equal to a squared minus b squared. That's a good one to memorize. And now we have to find b squared. That one's easy. B squared is just the other constant given in our equation, and that's going to be equal to 9. So we can say that c squared is a squared, which was 16, minus b squared is 9, and that's equal to 7. So this tells us that c is the square root of 7. And then we can go back up and write down that our foci are going to be located at root 7, comma 0, and minus root 7, comma 0. When we go to graph this, we need to know what the square root of 7 is. So I'm just going to write down here that the square root of 7 is approximately 2.7. Now let's find the eccentricity. We know that the eccentricity E is equal to c divided by a. And we know what c and a are, so we can just go ahead and plug that in. And it's going to be equal to c, which is the square root of 7, divided by a, which is 4. And then let's just make a note that the eccentricity is approximately 0.66. All you need to do is put root 7 over 4 in your calculator, and you can find that. Now let's go ahead and let's find the major axis length. That is equal to 2a. So this is just 2 times 4, which is equal to 8. This will be really helpful when we go to make our graph. Lastly, we need to find the minor axis length. This is equal to 2b, which is 2 times b, which we actually didn't calculate. So let's go back up here. I'm looking right here. This is going to tell us that b is equal to 3. We're just going to take the square root. Now we can go back down and plug that in. 2 times 3 is equal to 6. Now we can go ahead and sketch our graph. I've written down some steps that I think will help. The first step is to plot the center of the ellipse. The center of the ellipse is located at the origin, so let's just go ahead and put a circle right there. The second step is to sketch the major and minor axis. We know that the major axis in this problem is horizontal, and the major axis length is equal to 8. So that means we're going to move 4 units to the right and 4 units to the left. And then we can go ahead and put a point here and put a point here. Now let's draw the minor axis length. It is equal to 6. So we're going to move 3 units up and 3 units down. And then we'll add a point here and we'll add a point here. Now let's look at our third step. It says to plot the vertices and the foci. We actually already plotted the vertices, so I'm just going to label them with a V so we'll know which ones they are. Now we can go ahead and plot the foci. The foci, let's go back up here and see what they are. They are root 7, 0, and minus root 7, 0, and root 7 is 2.7. So let's march out 2.7 units to the right and 2.7 units to the left. And those are our foci. We'll put a little F there for the foci. Now we can go ahead and just sketch the ellipse, and then we'll add labels. Our vertex on the right is located at 4, 0, and our vertex to the left is minus 4, 0. Let's also put in that the top part of our ellipse is located at 0, 3, and then the bottom part is 0, minus 3. And then we'll put in where our foci are located. They are located at minus root 7, 0, and then root 7, 0. And that's it. We did it. Let's now look at another example. And with this one, our ellipse is going to be oriented vertically. This is the same example that we just looked at. We're going to find the vertices, the foci, the eccentricity, the major and minor axis lengths, and then we're going to sketch its graph. Here's the equation that we're given. Notice that this one has the center of the ellipse not at the origin. Let's go ahead and let's start with the vertices. Notice that our largest number is 25, and it is located under the y plus 1 squared. So that tells us that our major axis is vertical. To find the vertices of an ellipse that is not centered at the origin, we first need to find the center of the ellipse. So let's write down the center. To find the center, what we're going to do is we're going to take the x minus 4 that's up in our equation, set it equal to 0. So that gives us x is equal to 4. And then we're going to take y plus 1, and we're going to set that equal to 0. So we get y is equal to minus 1. So our center is located at 4, minus 1. Now we can go ahead and write down our vertices. Our vertices are going to be 4, comma, minus 1 plus a, because it's oriented vertically, and 4, minus 1 minus a. Our a squared was equal to 25. The a squared is always associated with the biggest constant, so that tells us that a is equal to 5. So we go back up here. Our vertices are going to be located at 4, minus 1 plus 5, and 4, minus 1 minus 5. So they are going to be located at the point 4, 4, and the point 4, minus 6. It's a little bit more work when the ellipse is not located at the origin. Let's now do the foci. The foci are going to be located at 4, minus 1 plus c, and at 4, minus 1 minus c. Now we need to find c, so we know that we can use the equation c squared is a squared minus b squared. Let's make a note that a squared was equal to 25, so that means b squared is our other constant, which is 16. Let's now plug these in. C squared is a squared, which is 25, minus 16. That is 9. That works out really nice. So that c is equal to 3. Now let's go ahead and put down our foci. Our foci are equal to 4, minus 1 plus 3, and then 4, minus 1 minus 3. And this is equal to 4, comma 2, and 4, minus 4. Now let's look at the eccentricity. That's equal to E, which is C divided by A. C was 3, and A was 5. So this is equal to 0.6. We now need to find the major axis length. This isn't too hard to find. It's just equal to 2 times A. Our A is equal to 5, so we have 2 times 5. So this is just equal to 10. We have one last thing to find. It is the minor axis length. It is equal to 2 times B. We found right up here that our B squared is equal to 16, so that tells us that B is equal to 4. So let's go ahead and plug that in. We have 2 times 4, and that's equal to 8. Now we can go ahead and sketch our graph. Here's the steps. They are the same as we just did on the last problem. We are going to start by plotting the center. Our center was located at the point 4 minus 1, so we'll march out 1, 2, 3, 4, and down 1. So there's our center. Now let's sketch the major and the minor axis. The major axis is vertical, and its length is equal to 10. So we're going to march out 5 units up, 1, 2, 3, 4, 5, and 5 units down, 1, 2, 3, 4, 5. And then we can go ahead and sketch that. Now let's do the minor axis. Its length is equal to 8. So we're going to go 4 units to the right and then 4 units to the left. And there is our minor axis length. Now let's go ahead and sketch the vertices. They are going to be located right here and right here. They're along the major axis. Now let's plot the foci. Let's go back up and see what they're equal to. They were 4, 2, and 4 minus 4. 4, 2 is located here, and 4 minus 4 is located here. Now we can go ahead and sketch our ellipse. I think it's always hard to sketch an ellipse and not make it look square. Mine looks a little square, but just try to keep in mind it's supposed to be a smooth curve. Now all we have to do is add labels. Our vertex at the top is located at the point 4, 4. Our vertex at the bottom is located at the point 4 minus 6. This point here on the right is located at 8 minus 1. And over here, we have the point 0 minus 1. And then let's go ahead and put in our foci. This one is located at the point 4, 2, and this one is located at the point 4 minus 4. Let's now look at some other examples that are more algebraic. In our second example, we are going to find an equation for the ellipse that has given foci and vertices. We're told that the foci are plus or minus 4, 0, and the vertices are plus or minus 5, 0. Because our foci and vertices have an x component that changes, that tells us that the major axis is horizontal. And because it's horizontal, we can write down that the equation that we're looking for is x squared divided by a squared plus y squared divided by b squared is equal to 1. Let's now write down what we're given in terms of a, b, and c. Our foci are plus or minus 4, 0, so that tells us that c is equal to 4. And then our vertices are plus or minus 5, 0, so that tells us that a is equal to 5. Now what we need to do is find what b is equal to. To do that, we are going to use the formula that relates a, b, and c, and that formula is c squared is equal to a squared minus b squared. Let's go ahead and substitute in c and a. This is 4 squared is equal to 5 squared minus b squared. So we have 16 is equal to 25 minus b squared. Let's pull the b squared to the left and the 16 to the right. So this is 25 minus 16, which is equal to 9. So we have that b, taking the square root of both sides, is equal to 3. Now we can go ahead and write down our equation. Our equation is x squared divided by a squared. A is equal to 5. We're going to square that, and we get 25 plus y squared divided by b squared, which is 9. I just realized that we probably didn't need to find b, even though we did. And this is all equal to 1. Let's now look at another example. In this example, we're again going to find an equation for the ellipse, but now we are given foci and major axis length. Our foci are located at the point 0 plus or minus 3, and then the length of our major axis is equal to 10. Because the y component of the foci changes, that means that the major axis is going to be vertical. Let's go ahead and write that down. So major axis, I'm having a hard time saying that word today. That tells us that our equation is going to be x squared divided by b squared plus y squared divided by a squared is equal to 1. The a squared is going to go under the y squared because it's vertical. Now let's see what we're given. Our foci are located at 0 plus or minus c, so we know that c is equal to 3. And then we're given the length of the major axis, and that is 2a, and we're going to set that equal to 10. So that's going to give us that a is equal to 5. Now all we have to do is find b squared. We're again going to use the equation that c squared is equal to a squared minus b squared. C is 3, so this is 3 squared, and then it's equal to a squared, so that's 5 squared minus b squared. This is 9 is equal to 25 minus b squared. Let's change sides. We'll pull the b squared to the left, and then on the right we have 25 minus 9, which is 16. We can now write down the equation. We have x squared divided by b squared, which is 16, plus y squared divided by our a squared. Here's our a. We are going to square it, so we're going to get 25. And that's equal to 1. Hang with me. We have 2 more examples, and they're different than the ones that we've just done. In example 4, we are going to find an equation for the ellipse, and we are given vertices and minor axis length. The vertices are 0, 2, and 8, 2, and then the length of the minor axis is equal to 2. In order to write down our equation, we need to first know where the center of the ellipse is. I'm just going to make a quick sketch, and let's go ahead and let's put down the vertices. Our vertices are located at 0, 2, that's right here, and then at 8, so let's say we're doing 2 units each, so 2, 4, 6, 8, 8, 2. We'll label this 0, 2, and then 8, 2. Our center of our circle is going to be midway between our vertices, so it's going to be located right here, and that's the point 4, 2. Let's also notice that our ellipse is going to be oriented horizontally, so our a squared is going to go under our x squared, but instead of having just an x squared, we are going to have an x minus 4 quantity squared. So we'll divide that by a squared plus y minus 2 squared to take into account that our ellipse is centered at 4, 2, and then the b squared goes under there, and that's equal to 1. Now we have to find a and b. The distance between our vertices is the length of our major axis, and that's equal to 2a. So we have 2a is the length of that green line, which is going to be 8. So that tells us that a is equal to 4. And then we are given the length of the minor axis, and that's equal to 2. So we know that 2b is equal to 2, so B is equal to 1. Now we can go ahead and write down our equation. Our equation is going to be x minus 4 quantity squared divided by a squared. There's our a. We're going to square it, so we're going to get 16 plus y minus 2 squared, all divided by b squared, which is 1, is equal to 1. Hang with me. We have one more problem to do. We're again going to find the equation for an ellipse, and this time we are given the eccentricity and the foci. The eccentricity is 1 divided by 3, and the foci are located at 0 plus or minus 2. Because the y component of the foci changes, that means that our major axis is going to be vertical. So our equation is going to be x squared divided by b squared plus y squared divided by a squared is equal to 1. Now we need to find a and b. We're given that our foci are 0 plus or minus 2, so that means that c is equal to 2, and we're told that our eccentricity is 1/3, and that's equal to c divided by a. Plugging in c is just 2 divided by a. So let's write it like this. We have 1/3 is equal to 2 divided by a. If we cross multiply, we get that a is equal to 3 times 2, which is 6. Now we need to find our b. To do that, we are going to use the equation c squared is equal to a squared minus b squared. I've saved this problem for last because I think it's the hardest. Let's now go ahead and plug in a and c. C is 2, so we have 2 squared is equal to a, which is 6, so that's 6 squared minus b squared. This is 4 is equal to 36 minus b squared. Let's pull the b squared to the left. So we have b squared, and then we'll pull the 4 to the right. So that's 36 minus 4, which is 32. Now we can go ahead and write our equation. Our equation is going to be x squared divided by b squared, which is 32, plus y squared divided by a squared. Let's see, where's our a? Here's our a. It's equal to 6. So we have 6 squared is 36. So we put a 36 here, and that's equal to 1. And that's it. You now know how to find the vertices, foci, eccentricity, and major and minor axis lengths of an ellipse, and how to write the equation that describes it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.